In the first question, you're looking for the differences between freezing point depressions. Now, the equation you'll be using here, the same one we've been using, delta TF equals I KF M. And in this problem, you are given the KF value, and the molality you're not given, but the molality can be calculated. And it's going to be moles of solute over kilograms of solvent. You are given the moles of solute here. It's going to be 0.12 moles. And you're given the mass of solvent, which is water here, 447.00 grams, and that needs to be converted into kilograms. So that allows us to pick up M as well. So the only difference between NaCl and CaCl2 is going to be the way that you would split them apart and figure out the I values. So if it's NaCl, it's going to be I equals 2 because there's 2 particles. Now CaCl2 is going to have an I equals 3 because it has 3 particles. So you can see now that what you would need to do is calculate the delta TF for CaCl2 and for NaCl, and then take the difference of those. But you're looking for an absolute value, so any number you come up with is going to be a positive value for the answer in question 1. In question 2, we're using the same formula, delta TF equals I KFM. We know what the I for NaCl is, and what we're looking for is the molality, and that means that we are just going to do delta TF over I times KF. We are given all of those values there. Since the freezing point of water is 0 degrees, that's pure water, we know that the delta TF then, we're just going to pick up the positive value, the difference between 0 and negative 13.7. It's going to be 13.7 degrees Celsius. And it will go from there. We'll pick up the molality that way. In problem 3, we're taking this one step further. We've got this to get the molality. And we also know further that once we have the molality, we know that molality equals moles of solute over kilograms of solvent. And again, we have the grams of solvent, which would need to be converted into kilograms. We do have the we don't have the moles. That's what we'd be looking for, because we already have the molality. We get that from this formula here, and we'd be getting the moles of solute, which is going to be the NaCl, and that's going to be then able to be converted into grams of NaCl, and we do that using the molecular weight. I don't think you should be able to do that. And in the bottom one, it's a similar problem to what we just did. And you can see I've already circled that x2, y5. That's the most important part of that problem. And what's going to change here is x2, y5, if I drew a picture of it, is going to look like this. So it would break apart into 7 particles. So the I here would be 7. And again, we would just do the same thing as we did in number 3, except with the different I value to adjust for the new hypothetical salt that we have here. And it would be the same kind of deal. We do have a molar mass here. That's the same as molecular weight. And we would use that in the problem, just like we did in problem 3, in order to figure out the number of grams of this hypothetical salt.